Lesson 14, I will find common units or number of units to compare to fractions. In the last couple of lessons, we've been comparing fractions using benchmarks and a number line. Well, today we're going to discuss another strategy for comparing fractions, and we're going to do this by finding common units or common number of units to compare to fractions. Now, I'm not going to have you get out your journal today. I am going to talk to you a little bit about some things before we get started on our problem set, but there's nothing for you to write down in your journal today. But I do ask that you please listen carefully to the next couple of slides before you get started on your problem set. All right, so the first thing I want you to think about to yourself is, which would be greater? If you were comparing one apple to 3 apples, which would be greater? Well, obviously, 3 apples is greater than 1 apple. So which would be greater, 1/4 or 3/4? Well, obviously, 3/4. What do you notice about these two statements? Well, hopefully you noticed that the units were the same. That you were comparing an apple to an apple and a fourth to a fourth. So when you compare fractions, if the denominators are the same, you can think of it as just like a unit, just like you would say 1 centimeter is less than 3 centimeters. Well, 1/4 is less than 3/4. So if your denominators are the same, then they're easy to compare. All right, so let's think about something a little bit different here. What if your denominators are not the same and you're trying to compare 1/4 and 1/5? Which would be the greater? Well, most fourth graders are going to say, well, 1/5 is bigger because 5 is bigger than 4. But actually, 1/4 is greater than 1/5. And here's how you know. Okay, if you took a look at a tape diagram, if you had two tape diagrams just like this, same exact, they have to be the same size, okay? If you had two tape diagrams the same size, let me just try this a little bit differently. If I took one and I divided it into fourths, okay, that's not perfect, but it's close. And I took one and I divided it into fifths, the more parts I'm dividing it into, what happens to the parts? Just like if I was sharing this with my friend. If I shared this candy bar with only 4 friends, we're going to get more than if I share this candy bar with 5 friends. The more parts, the smaller your parts. That is why a fourth is actually greater than a fifth. So if I know that a fourth is greater than a fifth, I can use that to understand this. 2/4 is greater than 2/6. Now let's think about this for just a second. What do you notice about both of these statements? Well, in both of these statements, the numerator is the same. So if the numerator is the same, then I can just compare the denominators. And the bigger the denominator, the smaller the part. So if I have 1/5, that's going to be less than 1/4. And because 1/4 is greater than 1/6, then 2/4 is greater than 2/6. Okay? All right, we're going to go ahead and skip ahead to our problem set today because our problem set is 3 pages long. So you're going to have a lot to do here. Go ahead and write your name and the date, and then let's get ready to get started. Okay, so it says compare the pairs of fractions by reasoning about the size of the units. Use greater than, less than, or equal to. All right, so first of all, I'm comparing 1/4 to 1/5, and that's exactly like what we just talked about. So that should be pretty easy for you to be able to identify which one is greater. If the denominator is larger, that means the smaller the size. So 1/4 would be greater than 1/5. Same thing if I have 3/4 and 3/5. Well, if a fourth is bigger than a fifth, then if I have 3/4, that's going to be greater than 3/5 because my numerator is the same. All right, so let's look at this one. 1/10 compared to 1/12. Well, the more parts, the smaller the size. So a tenth is going to be greater than a 12th. So if 1/10 is greater than 1/12, then 7/10 is greater than 7/12. So if your numerator is the same, then you can easily compare, okay? All right, so let's talk about this a little bit differently. It says compare by reasoning about the following pairs of fractions with the same or related numerators. Use greater than, less than, or equal to. Explain your thinking using words, pictures, or numbers. Problem 2B has been done for you. So they were proving that 2/5 is less than 4/9. And we're going to talk about what they did here. Now you'll notice that the numerators are not the same and the denominators are not the same. So that would be hard to compare. Okay, so let's take a look at what they did here so that they could easily compare them. They took 2/5 and they decomposed it into tenths. And by doing that, now their numerators are the same. So now instead of 2/5, they can think of this as 4/10. So they have 4/10 compared to 4/9. Well, because ninths are larger than tenths, then 4/10 is less than 4/9. So that's how they solved this. Now, I know that that's a lot to understand, so just remember we're going to be doing 3 pages of this problem set. So as we get through it, it'll start to become more clear to you. All right, so we're going to compare 3/5 to 3/4. So the first thing that we're going to do is we're going to go ahead and we're going to use a model. So you're going to draw 2 tape diagrams. Here's what's important about your tape diagrams. They need to be as close to the same size as possible. So make sure that both of these are the same size. All right, now we're going to go ahead and we're going to divide the first one into fifths. Ooh, my lines are not straight today. Okay, so 5 parts. We have 1, 2, 3, 4. Okay, this isn't perfect, but it's close. So now let's divide this into 4. So we're going to divide it in half, and then divide each half in half. Okay, so let's shade 3. 1, 2, 3. 1, 2, 3. So which would be greater, fifths or fourths? Fourths are greater because the more parts you divide it into, the smaller the parts. Therefore, 3/5 is less than 3/4. All right, let's take a look at C. You'll notice that our numerators are the same. We have 7/11 compared to 7/13. Now, we're not going to draw a model on this one, but we could. But here's what I want you to think to yourself. Which would be greater, 1/11 or 1/13? Which one would be greater? Well, the 11th would be greater because the more parts you divide it into, the smaller the parts. So if 1/11 is greater than 1/13, then 7/11 has to be greater than 7/13 because your numerators are the same. So this would be greater than. Now, when you look at D, you will notice that the numerators are not the same and the denominators are not the same. So we will have to draw a model for this one, okay? All right, so I'm going to go ahead. Ooh, not a circle. All right, I'm going to go ahead and start by drawing a tape diagram. Remember, these have to be the same size. Okay, so for the first one, I'm going to divide this into 7 parts. That means 6 lines. 1, 2, 3, 4, 5, 6 lines. So 1, 2, 3, 4, 5, 6, 7. And then this one, I'm going to divide this one into thirds. I'm going to divide each third into 5 parts. So that means 4 lines. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, now I'm going to shade. I'm going to go ahead and use my highlighter so you can see what I've got here. So here is 6 out of 7. 2, 4, 6, 8, 10, 12. There's 12/15. Very close, right? So it's kind of hard to tell from the model. So I need to either have, I need to find a common numerator or a common denominator. So if I take these sevenths and I divide them into halves, like this, okay, what began as 6 out of 7 is now, I'm going to draw an arrow right here. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fourteenths. So now I have a common numerator. So I have 12 fourteenths and 12 fifteenths. So my numerators are the same. Which would be greater, a 14th or a 15th? Remember, the more parts you divide it into, the smaller the parts. So 12 fourteenths is greater than 12 fifteenths. And since 12 fourteenths is equal to 6 sevenths, then 6 sevenths is greater than 12 fifteenths. All right, so let's take a look at number 3. Draw 2 tape diagrams to model each pair of the following fractions with related denominators. Use greater than or less than to compare. All right, so we're going to draw 2 tape diagrams again, just like we did before. All right, I'm going to leave a little bit more space in between them this time. Actually, I think I'm just going to do them side by side since I've got this room right here. But you need to make sure that your tape diagrams are as close to the same size as possible. So the first one that I'm going to model is 2/3. So let me go ahead and get my pen ready. I'm going to make 2/3. And then over here, I'm going to make 5 sixes. So I'm dividing this one into 6 parts and the first one into 3 parts. So now I'm going to shade 2/3. And 5 sixes. Remember, when you're shading, you have to be able to tell where your lines of division are. So you need to make sure that you shade very lightly. I can't shade lightly here. All right, now, I don't have a common numerator and I don't have a common denominator. Which one of these do you think would be the easiest to make the same? Would it be easier to turn this 5 into a 2 or this 2 into a 5? Or would it be easier to turn this 3 into a 6 or this 6 into a 3? Well, I could do it either way, but I think the easiest way to do this would be to go ahead and make a line of division right here. So now what I started with as 2/3 is now 4 sixes. So now I've got 4 6 compared to 5 sixes. So which one would be greater? Well, 5 sixes would be greater. So since 4 sixes is equal to 2/3, then 2/3 is less than 5 sixes. All right, so let's do the same thing for B. All right, so we've got 4ths and we have 8ths. So let's go ahead and draw our 2 tape diagrams. I'm going to divide this one into 4 parts. I'm going to divide this one into 8 parts. So I'm going to begin with 4ths, and I'm going to divide them in half. So remember, my whole strategy here is I'm trying to get either a common numerator or a common denominator so that I can compare these. So I'm going to go ahead and shade 3 out of 4 and 7 out of 8. Okay, so right now, my numerators are different and my denominators are different. So which would be easier? Would it be easier to make 3 and 7 the same number or 4 and 8 the same number? Well, I'm thinking I could very easily take this 4 and decompose it like this. So instead of having 3/4, now I have 1, 2, 3, 4, 5, 6 out of 8. And I'm comparing that to 7/8. So which would be greater? Well, 7/8 would be greater than 6/8. And since 6/8 is the same as 3/4, then 3/4 is less than 7/8. Okay, let's try this one. Now this one has greater than 1 whole. So that means that when we do our tape diagram, we're going to have to keep that in mind, that we have a whole plus some more. So I've got a whole, and then I've got another one. And these need to be as close to being the same size as you can make them. All right, so the first thing I'm going to do is I'm going to go ahead and divide this into, I'm going to mark part of it as the whole. So this is going to be the whole, and this is going to be the 3/4. Okay, and over here, this is going to be the whole, and this is going to be the 7/12. Okay, so these are fourths, so I'm going to divide this into 4 like this. So here's 4/4, and then over here I've got 3/4. Notice how they need to try to all be the same size. And then over here I'm going to divide the whole into 12 parts. So I'm going to divide them into fourths and then divide each fourth in 3. 12 parts gets a little bit tricky trying to model, but I think we can do it. All right, let's go back and count and make sure that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then over here I have to have 7 that are about the same size as this. So I've got 1, 2, 3, 4, 5, 6 lines should make 7. So I should have 1, 2, 3, 4, 5, 6, 7. Now I'm going to shade all of both of these because this is all 1 3/4. This is all 1 7/12. Okay? Now, first of all, they look pretty similar, don't they? All right, so let's start by determining which would be easier. Would it be easier to get this 4 to 12 or to get this 3 to 7? Well, I think it'd be easier to get the 4 to the 12. So I could take this and divide this into 3 parts. So I'm going to treat this as an area model and do this because it's faster. So now, instead of 1 whole and 3/4, I have 1 whole and 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12. So which would be more? A whole and 9/12 or a whole and 7/12? Well, 9/12 would be more than 7/12. And since 9/12 is the same as 3/4, then 1 3/4 is greater than 1 7/12. Right now it says, draw one number line to model each pair of fractions with related denominators. Use greater than or less than to compare. All right, so we're going to use a number line here. So let's go ahead and draw our number line. And this is, both of these are less than 1, so I'm going to use 0 to 1. I'm going to begin by dividing my number line into thirds. And here's 2/3, 1, 2 thirds. And then this is 5/6. So if I take my number line and I decompose it into half like this, now I have 1, 2, 3, 4, 5, 6 parts. So this would be 5/6. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So which one is greater? 2/3 is less than 5/6. But if you notice, 2/3 is also 1, 2, 3, 4 6s. So we could have compared it like that too. All right, so let's take 3/8 and compare that to 1/4. So again, neither one of these fractions are greater than 1, so my number line is going to be from 0 to 1. And I'm going to start with fourths because it's the smallest denominator. So I'm going to divide this in half and then divide each half in half. Now I have 1, 2, 3, 4 parts, and the first one would be 1/4. Right now I'm going to divide my fourths in halves to make eighths. So now I have 1, 2, 3, 4, 5, 6, 7, 8 parts. This is 1/8, 2/8, 3/8. So which one would be greater? 3/8 or 1/4? Well, 3/8 is greater than 1/4. All right, let's try this one. Again, neither one of these fractions are greater than 1. I can tell because the numerator is smaller than the denominator. So we're going to begin with 0 to 1, and we're going to divide this into 6 parts. I'm going to divide in half, and I'm going to divide each half into thirds, just like this. Now I have 1/6, 2 6s. So now I have to divide this into 12s. Well, that's going to be easy because I can take each 6 and divide it in half, and now I'll have 12 parts. So now let's just count over. 1/12, 2/12, 3/12, 4/12, 5/12. So which one's greater, 2/6 or 5/12? In this case, 5/12. All right, so now I have 8/9 and 2/3. So let's draw our number line. Again, neither one of these are greater than 1. They are both less than 1. So I've got 0 and 1. I'm going to begin by dividing them into thirds because that's my smallest denominator. So I've got 1/3, 2/3. And now I have to take these thirds and divide them into ninths. So if I take each third and divide it into 3 parts, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 parts. So I have 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9. So which one's greater, 2/3 or 8/9? 8/9. All right, now it says compare each pair of fractions using greater than or less than or equal to. Draw a model if you choose to. Now, again, we are faced with greater than, less than, or equal to. You've got a 1/3 chance of getting it right, so a lot of kids want to guess. So I'm going to say to you, I'm going to expect either a model or a brief explanation. So we're going to do these together. So I want you to take a look at A. Now, the first thing you notice about A is that the numerator is the same in both of these. So all I have to think to myself is, are fourths greater than sevenths? This is like the apple question. Would 3 apples, or no, sorry, this is not like the apple question. If I had 1/4 and I had 1/7, which would be greater? Well, fourths are greater than sevenths. So if I have 3/4, that's going to be more than 3/7. And I'm not going to write an explanation, but I am going to say this. 1/4 is greater than 1/7. That's why 3/4 is greater than 3/7. Now, when you look over here, I have fourths, 4 and 8, and fifths and 12s. Well, there's nothing I can do to 5 to get to 12, but there is something I can do to 4 to get to 8. So if you think back to when we used multiplication to make equivalent fractions, what if I did this? What if I multiplied the numerator and the denominator by a number so that I ended up with 8 as a numerator like I have here? Well, what do I have to multiply 4 by? I'd multiply it by 2. And if I multiply 5 by 2, because you have to multiply your numerator and denominator by the same number, now I have an equivalent fraction. 4/5 is the same as 8/10. So now I can think of this as, instead of 4/5, I can think of this as 8/10. Well, if I have 8/10, is that less or more than 8/12? Well, it is more because tenths are bigger than 12ths. Okay? All right, so let's take a look at C. The numerators are not the same. The denominators are not the same. Okay? But which would be easier? Would it be easier to get the numerators the same or the denominators the same? Well, there's nothing I can multiply 3 by to get 7. But I could take this 3/5 and I could use multiplication to get tenths pretty easily. What would I have to multiply 5 by to have a 10 as a denominator? Well, I'd have to multiply it times 2. So whatever I multiply the denominator by, I multiply the numerator by. So now I have 6/10. So now I'm comparing 7/10 and 6/10. Which would be greater? Well, 7. 7 is more than 6, so 7/10 is more than 6/10. All right, so let's take a look at these. My numerators are not the same, and my denominators are not the same. There's nothing I can do to 2 to get to 11, but there is something I can do to 3 to get to 15. So let's think about this. If I have 2/3, and I want to come up with an equivalent fraction that has 15 as a denominator so that these will have common denominators, I can multiply them both by what number? I can multiply them both by 5. So now I've got 3 times 5 is 15, 2 times 5 is 10. So instead of thinking of this as 2/3, I'll think of it as 10/15. So if I had 10/15 and 11/15, which would be greater? Well, 11/15, because if I have 11 of the same size, that's going to be more than 10 of the same size. All right, so let's take a look at E. I've got 3/4 and 11/12. There's nothing I can do to 3 to get to 11, but there is something I can do to 4 to get to 12. What can I multiply 4 by to get to 12? I can multiply it by 3. And whenever I do to the denominator, I have to do to the numerator. So now I've got 3 times 3 is 9. So 3/4 is the same thing as 9/12. So which would be greater, 9/12 or 11/12? 11/12, because 11 would be more than 9 if the sizes of the pieces are the same. All right, so let's look at F. So finally I got to one that I don't have to do anything to, because look, the numerator is the same. So all I have to think to myself is which would be greater, a third or a fourth? Well, a third is more than a fourth, because the more parts you divide it into, the smaller the pieces. So because 1/4 is greater than, or excuse me, because 1/3 is greater than 1/4, 7/3 is greater than 7/4. All right, so let's take a look at G. All right, so now I've got 1 and 1/3 and 1 and 2/9. Now the ones are going to stay the same, so I'm basically just going to look at 1/3 and 1/9. Is there anything I can do to 1/3 or 2/9? Is there anything I can do to 1/3 so that I will have either the same numerator or the same denominator? Well, look at the numerators. Could I do something to 1 to get it to 2? Well, sure, I can multiply it times 2. 1 times 2 is 2. 3 times 2 is 6. So I can think of this as 1 and 2 sixes. So now my numerators are the same. Which is greater, sixes or ninths? Which would be greater, 1/6 or 1/9? Well, 1/6 is greater than 1/9 because the more parts that you divide it into, the smaller the parts. So because 1/6 is greater than 1/9, 2 sixes is greater than 2/9. So therefore 1 and 2/6 is greater than 1 and 2/9. All right, let's take a look at H. So again, I don't have to worry about the wholes because they are equal. So let's take a look at the fractions. I've got 2 and 4 and 3 and 7. Well, there's nothing I can do to 3 to get to 7, but I can do something to that 2 so that I end up with a numerator of 4, just like I have in my other fraction. I can multiply the 2 and the 3 by 2. And now I have the equivalent fraction of 4 sixes. So I can think of this as 1 and 4 sixes. So which is greater, 1/6 or 1/7? Well, 1/6 is greater than 1/7 because the more parts you divide it into, the smaller the parts. So if 1/6 is greater than 1/7, then 4 sixes is greater than 4 sevenths. So this whole fraction is greater. All right, last problem. Timmy drew the picture to the right and claimed that 2/3 is less than 7/12. Evan says he thinks 2/3 is greater than 7/12. Who is correct? Support your answer with a picture. Well, when you look at the model, it's kind of hard to tell about which one is shaded. It almost looks like 7/12 is a little bit bigger. But I'm thinking, is there something that we could do to the numerators or the denominators to get them the same? Well, there's nothing I can do to 2 to get to 7, but what if I took these thirds and divided them into 4 parts so that they were 12s? So what if I did this? Come through here and I did this. Divide each one into 4 parts. Now, instead of 2/3, I have 1, 2, 3, 4, 5, 6, 7, 8 12s. So if 2/3 equals 8 12s, I can look at 8 12s and 7 12s. So which one would be greater? Well, 8 out of 12 is going to be more than 7 out of 12. Therefore, 2/3 is greater than 7 12s because 2/3 is equal to 8 12s. So who is correct? Well, Evan says 2/3 is greater than 7 12s. So Evan is correct. Now the reason why I don't have to explain my thinking is because notice it doesn't say explain, it says support your answer with a picture. And we did that, and we also supported it with a number sentence. Now I want to say that the last 3 lessons that we have done have been very tough. And you have to really try hard to focus and to understand. You may have to go back and rewatch a little bit of this just to make sure that you understand everything.